So the primary focus of this next series of videos in this section is going to be projectiles. But along the way, we're also going to do some work with parametric equations and how to describe motion parametrically. Now, you've done that before. All right, you did that in Calc 3, and it's not really difficult. But you may want to go back and review your Calc 3 with the parametric equations, just so you can kind of, help load all that stuff up into your head. Okay. So in this particular case, all right, we've got a little particle, and think of it like a bead or something like that. And we've got this notch, and the notch is moving to the right. All right. And so the bead has to stay in that notch, but then there's a groove, okay, there that it has the equation y squared equals 4x. There's that groove there, and so the particle has to stay in the notch and in the groove. So consequently, the little particle is going to move up sort of like that. Now, its position in x, which has to do with this, this slot, okay, is moving across, and that's given there at the bottom. X equals to 4t squared, okay? And so we can perfectly know everything about the x motion of this particular particle, okay? So in fact, let's go ahead, and while we're here, let's get the velocity, okay, which is going to be x dot. All right, that's our velocity in x. Okay, so we take our derivative, we get 16t cubed. All right, so there's the x component of the velocity as a function of time. Let's do one more derivative, then we'll have the acceleration. Okay, so that's x double dot, so a sub x. And so then that becomes 48t squared, like so. Okay. Just like that. All right. So we've done everything we can with x now. The thing we're trying the thing we're trying to find here is the magnitude of the velocity and the acceleration. Okay. Now, so it says magnitude there. So you're going to want to think at some point we're going to want to do x squared and y squared kind of a situation. We're going to need to use Pythagorean's theorem. All right. So kind of looking ahead, then what we're going to need is something like this. V sub x squared plus a v sub y squared. Okay. And then our acceleration is going to be an a sub x squared plus a sub y squared, like so. Okay. And it says at a particular time, 5 seconds. All right. So we actually already have the x and the components for the velocity and the acceleration. Okay. All we would have to do is put in the 0.5 seconds into these two equations here. All right. And we'd be good to go. What we don't have here is y. Okay. We don't know anything about y. If we knew y, then we could turn right around and we could pop that information here and here. Okay, so let's see if we can figure out how to do that. So the thing that relates the x and the y is our curve over here. Okay, and so this equation y squared equals 4x. All right, so here's how we're going to do this. We're going to say that y is equal to 2x to the 1/2. Okay, so 2 square root of x, that's what y is equal to. Now I know x is equal to 4t squared. Okay, so that means we can say this is 2 onto 4t squared. Woo! Sorry about that. It's t to the 4th to the 1/2 power. Okay, now when you work all of that out, what you get is square root of 4 is 2. 2 times 2, that gives us a 4 back. Okay, so we got this. And then square root of t to the 4th is a t squared. So we got our t squared there. All right. Now we have y as a function of t. Okay. And so we could take derivatives. Whoops. Looks like a G. Struggling with my handwriting here today. Y dot, okay, is our Vy. And that's going to be 8t. And then y double dot, that's our Ay. And that's just 8. Okay. There we go. Okay. So I'm going to let you finish this one up. Piece of cake. Again, all you're going to need to do is take this value for t, and you're going to put it in to our different equations here and here, and then wrap it up just like that. Okay. Plop your t in, take your square root of the universes, and you're good to go. Okay. Pretty straightforward.